Hello everyone. Today we're going to learn how to do geometry proofs, and using two triangles as our object here, we're going to prove the triangles are congruent by these two reasons. We're focusing on the angle side angle pattern and the angle angle side pattern. In the previous section of notes we looked at these two patterns, and now we're going to go through proofs showing that triangles are congruent by these reasons. And we want to just remind you that in each of these cases there are always two pairs of angles and one pair of sides, and what you're looking for is whether the side that we have marked is between the two marked angles, that's called an included angle, or whether the side is not between the two marked angles, that would be a non-included angle. Before we jump into the proofs, a bit of review. Remember that we create angle pairs in a situation where we have parallel lines cut by a transversal. And remember that we have a variety of different angles here, but if parallel lines are cut by a transversal, then we end up with certain pairs of angles that are going to be congruent. And a common pair that comes up in these kinds of proofs are the ones that are these alternate interior angles. So recall that alternate means you're on opposite sides of the transversal, and interior means you're inside the parallel lines. So anytime there's a proof that gives us parallel lines, that's pretty much a dead giveaway. We're going to be looking for some kind of angle pair. It doesn't always have to be an alternate interior pair, but that's a common one that we'll be seeing here. And here we go. So let's take a look at our first proof. Here we have angle G is congruent with angle B, and that's already marked. And also given to us is the parallel segments of segment CB with segment GA. Alright, so there's those parallel lines. So let's write that down in statement number 1. We could choose to split up these two pieces of given information and put them on statements 1 and 2, but if that's the case, then we would actually go longer. We would go to a statement number 5. So what you see here, the way we've outlined this is the shortest possible proof. You can't ever have fewer than 4 statements, but you could have more than 4 if you solve the proof in a different way, or if you were to take these two pieces and split them up on 2 different lines. That would just lengthen it a little bit. Here I'll just put them on the same line number 1. Of course that's given. So what we have listed here is actually our first pair of congruent parts. Remember, we have to have a total of 3 pairs of congruent parts before we can show that the triangles are congruent. So we found one, or we were given one. We have to find 2 more. These are not congruent parts. These are parallel lines, but they can form pairs of congruent angles. That's what we were talking about up here in the margin. So if it helps, you can kind of extend these sides as if they were your parallel lines, and you want the side that is shared between the two triangles as your transversal. So that means we're looking at angles that are touching the transversal and are touching the parallel side. So that's going to be this angle and this angle, right? You see how they're touching the transversal and they're touching the parallel sides. Okay? We can't just call this angle C because there are lots of angles that share this vertex at C. So we have to use a 3-letter combination. So we'll call this angle BCA. So angle BCA is congruent with angle GAC. And let's think of our if then. So these were congruent because of the parallel lines. So remember, the if part describes the line before. So if parallel lines, comma, then, once more, be careful, don't just say then angles are congruent. You have to describe what the name of those angles are. Then alternate interior angles are congruent. And so if you think about what we have so far, notice that we have 1 pair of congruent parts, 2 pairs of congruent parts. Remember, you always have to have 3 before you can say that your proof is about done. So we need 1 more pair, and that'll be on this shared side, right? So anytime you have a shared side, that'll be your reflexive property. So segment CA is congruent with segment CA. That's our reflexive property of congruency. So now that you've got 1, 2, 3 pairs of congruent parts, now you can declare that triangles are congruent. But we need a reason. Is it the angle side pattern or the angle side angle pattern? And that's why it's so important to keep track of your markings as you go through the proof. I always recommend you cover up one of the triangles. You can just focus on the markings on one triangle and look for the 2 angles that are marked. There it is. Where is the side that is between the 2 marked angles? This is the side. And is this where we have the tick mark? Is it between the 2 angles? No, the tick mark is not between the 2 angles. So this is an angle, angle, side pattern. You could say side, angle, angle, but we typically list the angles first. So angle, angle, side is what we would call it. And that's our first proof. In a case like this, these 2 triangles were side by side, touching on that same common segment from C to A. Notice the difference in this next diagram, where in this case the triangles that we're trying to prove are in fact overlapping. If you take a look at what triangles we're trying to focus on, we're looking at triangle MJN. So MJN is this big triangle on the left, and triangle NLM is this big triangle on the right. And because they are overlapping each other, it creates other little smaller triangles and smaller segments and smaller angles. There's more information here than what we really need. So I redrew them. So this is a common strategy that we can use. Pull those triangles apart, and we'll be marking up both diagrams. But oftentimes it's easier to identify the markings on a diagram like this where the triangles are separated instead of overlapping. Alright, so let's find these angles and mark them on our diagram. Angle JMN. JMN is this angle, which is also on this big triangle on the left-hand side. JMN is congruent with angle LNM, which is this angle here at N. So if you mark it, you've got to write it down. So angle JMN is congruent with angle LNM. Now again, there's 2 pieces of given information, and we could put both of those on line 1, but I want to demonstrate what would happen if we split them up and put them on 2 different lines. Again, the way we've outlined this is the shortest possible proof, but we can always make it longer, and that's what we're going to see happening here. So this second pair of given pair of angles, angle JNM, that's this angle here. So now you can see why it gets really complicated to keep these triangles overlapping each other. It's a whole lot better to split them up like this so you can see the markings more clearly. This angle is congruent with angle LMN. I'm giving that a double arc, like so. I'll put this on line 2. So angle JNM is congruent with angle LMN, and that's also given. So if you count what we have 1 pair, 2 pairs of congruent parts. You always have to have 3, so that means we're needing to find 1 more. So let's go back to the diagram and see what we can find. Well, these 2 triangles, as we pulled them apart, redrew them, it might not be as clear than the original diagram where they share a common side. So right here is where the 2 triangles overlap a common side. And you can see that because they have the exact same name, segment and M, segment and M. If they have the same name, that means they are in the same place. That means they overlap each other. So we are allowed to put a tick mark here on that segment, and once again, this is our reflexive property. We're saying segment NM on the left triangle is congruent with segment NM on the right triangle. Reflexive property of congruency again, and now you can see we have 3 congruent pairs of parts, And what that means is now we're ready to say the triangles are congruent. But we ran out of lines. No worries, just add as many lines as you need to get the proof done. And we have our 3 pairs of parts, so that's how we know we can stop looking for more parts, and we can just declare that the triangles are now congruent. So triangle MJN is congruent with triangle NLM. And now we have to look at the markings on the diagram. So look at one of these triangles. You see the 2 angles that are marked. You find the side that's between. Does that have a tick mark? Yes, it does. So the side is between the 2 angles. So it's an angle, side, angle pattern. So this is an example of how we might end up making our proof a little bit longer than the provided outline of the proof, just because we split up the given information over 2 lines instead of 1 line. And that's okay. You have that freedom to do that if you like. Let's take a look at our 3rd example. And once again, you can see from the diagram, it looks like we may have overlapping triangles, but there's lots of little triangles inside this quadrilateral. So we do need to look at what the goal is to identify what part of the diagram we're looking at. So I'm starting off with what we have to show before we are looking at what we're given, because I want to know which triangles to focus on. So look at triangle AED. So that's this leftmost triangle, and then triangle BEC. Okay, so it turns out that the triangles we're working with do not overlap. They happen to be next to each other. You can redraw them, but I'm just going to outline them so we can see the parts of the diagram we need. We need this triangle on the left, triangle AED, and we need this triangle on the right, triangle BEC. So again, I'm going to outline this. And so what that means is we have more information than what we really need. That is, we don't need this segment at the bottom, segment DC, because that's not a side on our triangle. Same with segment AB, we don't really need that, so you can just pretend that's not there. We're focusing on this sort of butterfly pattern, or this bow tie pattern, with these 2 triangles sharing point E. Alright, so, well, you notice now there's no numbers provided here for an outline, so how long is it supposed to be? We'll find out. Here's our first piece of given information. Segment AE is congruent with segment BE. So let's mark that up. Segment AE congruent with segment BE. I'll go ahead and put this pair of angles on line 2. Angle ADE is congruent with angle BCE, also given. Now you got to mark it. A common mistake is that I find some of my students forget to mark the diagram, and then they forget how to identify, or they can't identify the pattern of the markings to know whether it's an angle side angle or angle angle side pattern. So always, if you name it, you got to mark it, and vice versa. So angle ADE and angle BCE. So that's the given information. That's sort of the starting position. And if you count, you can see we have 1 and 2 pairs of congruent parts. You always have to have 3. So we need to go back to the diagram and find another pair of parts. So we happen to have vertical angles. Here are these angles on either side of point E. Right? Vertical angles are always congruent. Don't call this angle E. We have too many other angles that exist at E, and we don't want to confuse which angle we're talking about, right? So we need this angle on the right, so it's angle BEC. And we need this angle on the left, that's angle AED. Alright, so if angles are vertical angles, then they are congruent. If angles are vertical angles, then they are congruent. You can now see that we have 3 pairs of congruent parts. 1, 2, 3. That's how we know we're ready to show that the triangles are congruent. Triangle AED is congruent with triangle BEC. Alright, so now we need to identify the pattern, and we've been marking all of our sides and angles as we go along. So again, cover up half the diagram, look at just one triangle, find the two marked angles, find the side between those two angles. Is that where the tick mark is? No, it is not. It is the side that's marked is not between the two marked angles. So this is an angle, angle, side pattern. Alright, so we ended up doing that in 4 steps. Notice we could have done that in 3 steps if we had combined the two pieces of given information into one line. So our last one, is going to be a little bit longer, and it turns out to be longer just because of where we're starting. In the previous proofs, they were giving us pairs of congruent parts, and yeah, we have one of those too. But here in this particular setup, we are starting with perpendicular segments. So again, we're trying to show that these two triangles are congruent, and you can see that they have a common side right here. So let's go ahead and get started. And what I'm going to do is I'm going to group these given pieces of information like this, because the first two are about perpendicular lines. I'm going to group those together and put those on one statement, and then I'm going to save these congruent parts for a different given statement, because they don't really go together. The perpendicular lines lead us to one conclusion, and the congruent parts is something else. So let's just focus on the perpendicular segments here. So segment ST is perpendicular to segment TW, and segment VW is perpendicular to segment WT. Now, if you think about what that means, segment ST is perpendicular to TW. We don't really have a symbol for that, but we know that perpendicular lines form right angles. So what we're doing is we're actually marking the right angle, but that in itself doesn't tell you that the lines are perpendicular. It's the perpendicular lines that form the right angle. So if you've marked it, you have to name it. And so on line 2, I'm not going to use the other piece of given information yet. I need to name this angle. Again, don't call it angle T, because there's lots of angles at vertex T. Call it angle STW. And I'm going to add some more detail. We're not done with line 2. But I want to mark both angles that come from these perpendicular segments. So we have segment VW, which is perpendicular to segment WT. So if those are perpendicular, again, they form right angles. So if I've marked it, I have to name it. So I'm going to name both of these on line 2. So we've got angle STW already. Now we need angle VWT. What are we saying about these two? We're not saying they're congruent yet. All we're saying is that we have right angles, because that's what is formed when we have perpendicular lines. So we're going to say these two angles, angle STW and angle VWT, are right angles. So you have to name them first before you can say they are congruent, because perpendicular lines form right angles. And if we only did one at a time, we would say these perpendicular segments form a single right angle, and these perpendicular segments form a single right angle. We could split that up on separate lines, and then we'll say that the right angles are congruent in a moment. So think of your if-then statement. If perpendicular lines then right angles. And what we're saying here is that they form right angles. That's your definition of perpendicular lines. And you could use that too if you wanted. Alright, well now what do we know about right angles? Alright, we know right angles are going to be congruent to each other. So now we say angle STW is congruent to angle VWT. How do we know that? Well, if angles are right angles, right, the if part always describes what came before. What came before on line 2 was that we had right angles, so if our angles are right angles, then they are congruent. Alright, so notice that we didn't touch that second piece of given information. We're about to bring that in just a moment. I focused just on the parts that had to do with the perpendicular lines because there was a train of reasoning we had to go through. So notice that we started with perpendicular lines. Perpendicular lines form right angles, and right angles are congruent. So this is now our first pair of congruent parts. Remember, you have to have 3 total to show that triangles are congruent. So it took a couple of lines just to get to our first pair. Well, here's our second pair that's also provided to us. So on line 4, here's our other given line of angle VTW is congruent with angle SWT. And that's given. So this is one reason why we might choose to split up given information. It's almost like if you were outlining sort of an essay. This is topic number 1. This is paragraph number 1. These are all the things you know that come as a result of your topic sentence of we have perpendicular lines. And then there's a little bit of a transition, and now you're bringing in your next topic sentence. And it's a very short paragraph because we already concede now that we have a pair of congruent parts. And then we're going to transition again, and we're going to try and find another topic sentence. And this will be our third pair of congruent parts. And this is the shared side. Right, so segment TW is congruent to itself by the reflexive property of congruency. So I use this analogy of like outlining an essay because you've taken English classes before and you've probably had to outline something. And so if you can see how this is similar to an outline of ideas, and each sort of congruent pair of parts here is its own paragraph, then you can see how these 3 lines are grouped together because they flow naturally from what was given. These 2 tend to stand on their own, and now we finally have our conclusion. And this is where we say the triangles are congruent. We have to look at the markings in our diagram to see what pattern to use. So cover up one of those triangles. And you know what? I forgot to mark that angle here. This was given to us, and I wrote it down and forgot to mark it. Let's do that. Angle VTW is up here, and that's congruent with angle SWT. That's there. Okay, now we're ready to look at our markings. And I see 2 angles that are marked. I look at the side in between. And sure enough, there's a tick mark on that side, so yes, we have an angle side angle pattern. And our proof is done.